Hello and welcome to this channel. I am Manasi and I am working in the role of data engineer, and I am very excited and happy to start this series. The series name is SQL for Data Engineers, and in this series I will be covering the SQL which is used in the data engineering, and we will be explore various use cases in the data engineer role for SQL especially. So let's get started. First and foremost, I will be start this series by covering the basic SQL, not from the very basic like select, group by, from these clauses, but yeah, from the basics which is required for further SQL series. So for this, if you know order by, group by, clause, select, where, from, etc. clauses, it's very enough to get this and start with the data engineer part. So yeah, so as we know, the SQL stand for structure query language. This language is basically used for the manipulation and modification, managing the relational databases. This means the SQL language is a standard interface for interacting with the relational databases, for managing and manipulating with the day-to-day use cases or day-to-day requirements. Before get deep dive into the SQL, so let's set the SQL overview first. DDL, data definition language. This includes like the creating schema for table, specifying the data types for particular columns, or specifying conditions with the data type, like the column should not be null or column may be null or empty, defining foreign keys, primary keys, etc. Next is data manipulation language. Here also, as the name suggests, the data manipulation language is used for manipulating, modifying the relational database systems or the data in the relational database systems, which includes insert, update, alter. Next is data querying. SQL allows multiple users to retrieve the data or retrieve the information from specific data sets using the SQL queries. Users can specify conditions, filters, joins, and the sorting or grouping of data to retrieve the required information. Then next is data modification. SQL language enables users to modify, delete, update, insert data. This comes in the category of data modification. Then the very important factor is data integrity. So data integrity is very important, and the SQL allows the defining of data integrity by defining the constraints. Constraints ensures that the data or the columns should follow the specific rules, uniqueness. This is called data integrity. Next is data security. So SQL or the structure query language provides or allows users to provide the security to the databases or data sets, because the data is very important nowadays. So in this case, there are some administrator roles which are responsible to provide users, the specific users, specific access to perform the specific operations on the specific datasets or databases. The next is data transaction. So transaction is consecutive SQL statements which are act as a single unit of work. Transaction ensures data consistency. So if users can commit their changes and the committed changes are successful, then the changes will be remain same in the system. But if the changes are failed to commit or there is an issue, then there are option to roll back it. Next is data aggregation and analysis, which includes group by, order by, and some aggregative functions like sum, average, like that. So the aggregation or aggregative functions are used for data analysis, reporting, to fetch the summary for the business purpose from the huge data. Then next is data indexing. So data indexing is very important, like data aggregation in the data engineering field. So SQL allows the creation of indexes for data or for tables. Indexing significantly improves the performance of retrieving the data by SQL queries. And the next is data retrieval optimization. This is also very important in the data engineering field, because if you write a SQL query or SQL script of thousands of lines, which is performing some aggregation, some analysis, some analytical reports from the large data sets or many data sets at a time, then the query should be optimized, or it should retrieve the data in the required time. Otherwise it will not useful. Yes, but we are focusing on the only SQL which is using or which is being used in data engineer practices, or the SQL which is must know, or SQL practices which are must known to us for data engineering aspirants or data engineers. So before that, let me clear what is OLTP and OLAP. So this is very important to know before starting for the further series. Actually, these approaches are very different, but let me give you some overview and the role of these approaches in the data engineering. So coming to the OLTP and OLAP, so OLTP stands for Online Transaction Processing, while OLAP stands for Online Analytical Processing. OLTP and OLAP serve two different purposes. Let's see. So coming to the OLTP, these systems are specially designed for day-to-day transactions or day-to-day operations, adding, modifying, deleting records in DBMS. Talking about the structure of data in the system, data is designed to minimize the redundancy and to ensure the data consistency. This is achieved by breaking the data into smaller tables which are related to each other. These systems mainly handle simple read-write operations, data retrieval operations, and the main focus is that to retrieve the single or very few records at a time. So example use cases where the OLTP is used in our day-to-day life. Common applications which uses OLTP systems are e-commerce websites, data inventory, data management, banking, order processing, etc. Let's come to the OLAP, which means Online Analytical Processing. As the name suggests, OLAP systems are designed for the analytical operation. These involve some complex queries, aggregation, for data analysis and data reporting for business purposes. These operations require large volume of historical data. And not historical data, we can implement analytical processing system for real-time data as well. So the business unit of organization can take a decision on the real-time report. Coming to the structure of OLAP system, which is totally different from OLTP. So the data is stored in the denormalized form so that the retrieval of data will be easy for analyzing or the complex queries or the aggregated queries. So for this, data is typically arranged in the data warehouse or data mart. As I told earlier, OLAP system or OLAP includes the complex queries, which includes aggregations, sum, average, grouping, ordering, sorting. So these queries are mainly designed to gain the historical or real-time insights on data. Main focus is not for read and write, but so the OLAP systems are optimized to ensure the easy retrieval of data through queries. Coming to the business use or real-time use of OLAP, OLAP systems are commonly used for business intelligence, data analysis, reporting, gaining data insights, which includes sales, financial, banking, reporting, data mining. So now the question is, between OLTP and OLAP, exactly which is going or which is being used in data engineering field? So we will see the answer of this. In data engineering, both OLTP and OLAPs are emphasized, but the use depends upon the focus or main objective of the process or specific task of data engineering. So let's see OLTP in data engineering. OLTP includes data ingestion. So data engineers work in the OLTP systems to ingest the data through data pipelines. Data can be or data ingestion can be from websites, from real-time sensors, or the transactional databases. Data transformation. Raw data ingested from OLTP systems or OLTP sources may need to be transformed to a feed or specific schema or structure before it is loaded into data warehouse or data lake. These transformation steps often involves cleansing, validation, or aggregation of data. Next is data integration. Data engineers integrate data from various sources of OLTP systems to create a unified view of data within organization. This integration can involve the aggregation or the merging of data from various databases, various applications, into the single data warehouse. Let's say OLAP in data engineering, data warehousing. Data engineer designs and maintain the data warehouse or data mart that are optimized for OLAP operations. These data warehouse or data mart structures allows the efficient querying for historical data for further analysis, reporting, or gaining insights. Next is data modeling. In OLAP, data engineers create multidimensional data models, which makes it easier to analyze the data further, and hence the data scientist can query the data, which includes facts and dimensions and hierarchies. Next is ETL, extract, transform, load. OLAP data is often transformed using extract, transform, load methodology to prepare it for reporting and analysis for business use. This includes the aggregation, summarization, grouping, etc. Next is business intelligence. Data engineers support business intelligence tools like Power BI, Looker to ensure that the data is available and well structured for analysis. So that's it for today. In the next video, we are going to configure the SQL platform. We are not going to install any software, so don't worry. We are looking into the configuration of SQL platform, which is very easy and useful for us to get started with the SQL for data engineering. Also, I will try to keep this series as interactive in such a way that I will be covering a topic or a scenario in a video, and we will solve some real world questions, or we will see some use cases on each topic, and I will give you some questions for practice to solve by you, and we will be discussing the answer or the approach for the questions in the next video. Please subscribe the channel and connect me on the LinkedIn. I will provide the link in description as well.